Hello everyone. So in this video, we are going to learn about a very interesting topic, which is the CAP theorem. This theorem helps us to understand what kind of system we are designing and what is our main focus when we are designing a system, a distributed system. Let's learn this with an example. Let's understand it with an example. Let's say we have an application A, we have a database node, and we have another database node. So basically, this is an application A, this is a DB node, we are calling it B, and this is a DB node, we are calling it C. And they are all, sorry, and we are calling it as C. And they all are connected. Of course, these are database and they are in sync. So this is sync basically. And let's say one more thing, that this database is in India and this database is in US. Okay, and this is our application. Now this has to be in sync, of course, because we don't want different data on database. So let's say this application is updating something on this database. So these databases are getting updated. They are in sync with each other. So this is called consistency. What is consistency? Consistency means that having the same data across all the available database at the same time. So this is called consistency. So if it has some data, so it should all automatically have it. Or if it has something that is updated later on, then it should also get synced with it. So this is consistency. Availability means an application should return some kind of response, either a success response, either fail response, but it should not go down. It should not be dead. So it should respond in any scenario, right? It should not be dead. It can fail, but it should not be dead. Means that all of the nodes of our system should be up. They should not be crashed. Means, let's say this is an application server, so it should be up. This DB node should be up, and this should also be up all the time. Means if our any of this node is down, let's say this is down, then our system is not available. We will not call it available. Okay, so there is a certain confusion in this, so please listen to it again and you will understand. Now understand about partition tolerance very carefully. I'm gonna explain it in a very layman terms. Let's say these are two databases, okay, and for some reason there is a connection breakage. Means this database is not able to send a sync request, update request to this database, or vice versa, which means now these databases are not getting synced together. But if I request some information from this application, I am still able to receive the data from B or C. Okay, which means even if there is a connection breakage among two DB nodes, the application should be able to still run normally. System should not crash. This means there is partition tolerance. Okay, so what happened here? These databases are divided into two separate databases. Of course, they were separate before as well, but they were in sync and they were connected. But now they are not connected, but I am able to still operate on those two, but separately. Now you may ask that what will happen to consistency, right? Yes, we will come on to that. So this is just a scenario I want to explain. Now, if you are able to see this diagram, you can see that in CAP theorem, we have three pillars: consistency, availability, and partition tolerance. On the basis of these three, we will decide what kind of uh, structure or design we will do, because if we are able to tolerate little bit of inconsistency, then availability and partition tolerance we will keep in mind and design our application around it. If partition tolerance is not required, then we will focus more or less on consistency and availability while designing, and we will choose components and theorems and algos around that. Same goes for if we are choosing consistency and partition tolerance, uh, and we may compromise with a bit with availability, then we have to design For example, for Facebook, let's say we are designing a Facebook, so it's a social platform, or WhatsApp, it's a social platform. We cannot accept a crash of this one, right? For a moment, if WhatsApp crashes or Instagram crashes, most of the people or creators go wild, like, oh my god, what happened, right? So this is one thing. uh, let's talk about design later, but let's see. And one important point is, in CAP theorem we cannot have all three together. So all three cannot goes together, and why, we will discuss about it as well. So here either we can have two things together, but not all three. Now there is a question arrive, why all the CAP cannot be used together? Why can't we do it? And how come? Let's say we will do kind of a case study here. Now let's talk about, let's let's see about case one. Case one, okay. Now this is a case one. Here there is a breakage, okay. There is some connection breakage between these two, okay, which means they are not in sync anymore. They cannot be synced. If some request come on application A, and for the first time it's sent to B, and some record got changed from 1 to 2, then this update cannot reach to C because there is a connection breakage. Also, vice versa as well. Let's say some requests come here from, let's say, 1 to 4, and this cannot be updated here because there is a connection breakage. But what is happening here? Our application is still available because we are able to handle these requests. It's not crashed, it is responding us. If someone asks A that give me the value that is in B, so B will send 2. But is it latest data? No, because later on we saw it change 1 to 4. But since this request was received, let's say from an Indian user, so it got 2. But if someone is accessing it from US, then he or she may get 4, right? So what does it mean? It is not consistent. Data is stale for this user. So, but is it partition tolerant? Yes, because both of the databases are still responding to us and we can access the data. However, it is stale. It may be a little outdated, and later on when connections comes up, it will sync together. But at this particular moment, it is stale data. So what does it mean? It means our application is available and partition tolerant. Okay. So here we cannot have consistency because it's broken. Now let's come to case B, second case or second scenario. Now let's look at the case number second. I can take the same diagram, and we will, so basically we are looking at a scenario second, that what can be the possibility, and then we will discuss what is it, right? Okay. So let's say everything is right at the moment, nothing is broken. All right. Now, now let's say we want to make sure that our database is consistent, but there is a breakage in this connection. Now we have to make sure that our data is consistent. Now, and how can we achieve that? There is only one option, that we have to put this database down, because if we keep this up, then there will be some updates, and and data will be inconsistent because it won't be able to send updates here because of this connection breakage, right? So we have the same scenario, its connection is broken, but we want to make sure that our application is consistent. Now what is availability? Availability means that our application should respond, it should not crash, right? But we have literally made one node down, which means our application is full application is not no longer available. I means our system is not fully available because one of our node is down. So we are consistent, yes. We are partition tolerant, we can say that as well, but we are not available because our node is down. So this is AB, AP, sorry, this is CP basically, consistence and partition tolerant. Now let's look at the scenario second. What is the another possibility? Now in this, we want to make sure that our database is consistent and our system is available, which means none of this node should be down. Now what is happening? Same scenario, our sync is broken. We want to make sure it is consistent, and we want to also make sure that it is available. And can we make sure that it's partition tolerant as well? Mm, I think no, it's not possible because we have to stop all the write requests to the database, because if we keep the write open, then again we will lose consistency, because there might be updates in one or in two, and it may cause inconsistency, right? So but and what we wanted our system to be consistent and available. Available means all the nodes should be up. There should be no node which is crashed, which means it has to be available. And for consistency, we have to make sure that database contains the same data. They should not have stale data. So we have to stop write requests. But partition tolerant is gone because we are no longer serving users. Of course, we can open read-only system, but again, it will defeat that purpose, because we are literally stopping a functionality of our application, right? So this is now what is we are consistent and available. Okay, so this is one thing. Now, out of this scenario, just always remember that never ever trade off partition tolerance, because we really want users to serve under any circumstances. So never lose partition tolerance. We want them to be able to read and write in any case. We don't want to stop any functionality of our system, of our application. So never ever trade off partition tolerance. So there is only two choices that you have to choose from, which is consistency or partition tolerance, or availability and partition tolerance, because we want our application to always able to serve user. We don't want our application to stop any functionality. So this is we want, right? So all right guys, this is all for CAP theorem. I hope you like the video, you understand. If you have any questions, feel free to comment down and I'll answer as fast as possible.